Okay, for this problem, you're given this function and asked to find out where there are horizontal tangent lines on the graph of that function. Well, we have to find the first derivative of this function and set it equal to 0, and that's going to require the quotient rule. That's the easy part, finding the first derivative. Finding out when the first derivative equals 0 is not so simple. But let's just go over the quotient rule. Denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. And if you multiply these two binomials together, distribute this 4x cubed, or you can think of it as minus 4x cubed, then combine similar terms, this is what you get in the numerator. And when does that equal 0? It equals 0 when the numerator equals 0. So that's the question we have to answer. When does this polynomial function equal 0? If I go to board 6, actually here's a graph of the derivative. And by the way, if you go to Desmos and graph both of these, f prime of x and g of x is that expression that we got for the first derivative, you'll see that the graphs are identical. And you can kind of pick up where those graphs, that the first derivative crosses the x-axis. Negative 1, 0, we could have gotten by using the rational root theorem. These others, not so easy. But that's where there are horizontal tangent lines. And there's what it looks like. There's the graph of f of x, this red curve. And there are the horizontal tangent lines, 3 of them. How did I find out these values? Well, I use something called Newton's method. There's the function we want to know, when does it equal 0? And if you're not familiar with Newton's method, another method would be to graph this function on a calculator and then use the intercept function on the calculator to find out where it crosses the x-axis. But Newton's method, well, it gave us negative 1 for one of the roots. But here's Newton's method with an x sub 0 of 0.4. And there is the value out to however many decimal places that is. And there it is starting at 2.1, giving us a root of 2.0689, blah, blah, blah. Okay, so that's kind of the technique you have to use. The question is, what technique are you going to use to actually find these 3 roots and to how many decimal places? I will post links to both Newton's method and the graph of this function in the video answer. There you go. Hope that helped. If you have any questions, post a comment.